Hey, Organic Chemistry. This is Quiz 2B, corrections that you're going to do. I'm going to go through the answers. You are going to correct your answers and make sure for your correction, you tell me what you did wrong. That's in order for you to get full credit. All right, so let's look at this first one. All right, the first one, we are naming the following organic compounds. The first one is a ring. One, 2, 3, 4, 5, 6, 7. This is a 7-membered ring, and I'll tell you why I numbered it this way. This is a 7-membered ring. This is cycloheptane. That's the parent name for a 7-membered ring, all single bonds. So 7-carbon ring, all single bonds. 7 carbon means hepta. All single means ane. And then it's a ring, so cyclo. So cycloheptane. All right, and now we have these two substituents. These are ethyls. Right? Methyl looks like one line, or it'll look like this. This is not methyl, this is ethyl. There are 2 carbons, and so ethyl. Okay? Now, the reason why I numbered it like this is because you want your lowest set of numbers when you number substituents. The only way that I could get lowest set of numbers is if I number one of my substituents 1. What if you went the other way? What if you did 1, 2, 3, 4, 5, 6, 7? I would get 1, 7, and I'm doing something with these ethyls. No. 1, 2 is going to be smaller. And then if you put those numbers anywhere else, they're going to be higher than 1. Anything is higher than 1. So I have 1, 2. All right. Now I have 2 ethyls. If I have 2 ethyl groups, we use the Greek prefix di. So diethyl. That means I have 2 ethyl groups. 2 ethyl groups on carbons 1 and 2 means the way that I name this is 1,2-diethyl cycloheptane. All right, now let's look at the next one. You have to identify and find the longest chain. 1, 2, 3. Nope. 1, 2, 3, 4. Probably longer. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 is definitely my longer chain. Some of you did not get here. Some of you called this ethyl and you said that this was your longer chain. So that was a correction that you have to make. So I have a 7-carbon chain, again, all single bonds, but no ring. We call that heptane. Now I have to talk about and name, oops, my flash went off. Now I have to talk about and name these substituents. Okay, so I'm going to circle them. 1, 2, 3, 4, 5. I have 5 substituents to talk about. This is bromo. And all of these, like I mentioned over here, all of these are methyl, and there's 4 of them. So we have to figure out how I want to number this. All right, so I'm going to use 2 different colors to number this. I'm going to number it left to right and then right to left. Whichever one gives me my lowest set of numbers is my answer. So 1, 2, 3, 4, 5, 6, 7. Or I could go the other way. I could do 1, 2, 3, 4, 5, 6, 7. And so now I got to figure this out. If I go from left to right, the way that I'll be using these numbers for substituents would be 1, 2, 3, 4, 5 with the methyls, and then 5 bromo. 5 with the methyls, and then 5 bromo. Or I'll go the other way. I'll be doing 1, 2, I'll have 3 with the bromo. And then I'll have 3, 4, 5, 6 with the methyls. In looking at these numbers, I could clearly see that these are going to be my lower set of numbers. 2, 3, 4, 5, 5 is going to be lower than 3, 3, 4, 5, 6. And so now I have to use these to name my compound. Now, I know I got 5 bromo. If I have 2, 3, 4, 5 methyl, that means I have 4 methyls. the way that I name 4-methyls is tetramethyl. And I need to use the numbers to tell you where they are. Tetramethyl with an M is going to come after the 5-bromo. So the way that I would name this would be 5-bromo, and then 2, 3, 4, 5 tetramethyl heptane. That is how I would name this compound. All right, so make sure you look out for, some of you used the wrong numbers, you numbered the chain incorrectly, some of you didn't give me the full chain, a lot of you forgot the bromo, don't forget that that's there, okay? All right, so now let's look at the last two. Draw the following organic compounds from the IUPAC nomenclature. All right, so it says 2,2-diethyl. Ethyl looks like this, or CH2, CH3. Looks like a bend, or a CH2, CH3. It says diethyl, which means I'm going to have 2 ethyls. And 2,2 means they're on the second carbon twice. 2,2 means I have something on my second carbon twice. 2,2. If I had 2,2,2, that would mean I have 3 things on my second carbon. And then 5-T-butyl. A lot of you did not get this substituent right, but T-butyl looks like this. It looks like a T, and then it's got a little squiggly line. Or it has C, and then CH3, 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 and then it's connected to your parent chain. I saw some of you do this, and this is not T-butyl. Like, you had the 3 CH3s, but like this was part of the parent chain. And that is not correct. You just gave carbon more than 4 bonds. More than 4 bonds. That's not okay. So if you did this, make sure you make a note that you gave carbon more than 4 bonds. Not okay. All right, so I have 5-T-butyl. So on my 5th carbon, I have this T-butyl. On my 2nd carbon, I have 2 ethyls. And then the parent name is nonane, which is 9 carbons. And then it ends in ane, so single bonds. So now let me draw out nonane, which is 9 carbons. So I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I get to number this whichever way I want. 3, 4, 5, 6, 7, 8, 9. I'm numbering it, so I get to tell you where I want to put things. So 2,2-diethyl. That means on my 2nd carbon, I have 2 ethyl groups. 1, 2. Done. Now, it doesn't matter how you do it. You could do up and down. You could draw it like this blown out. That's fine, as long as you have 2 ethyl groups on your 2nd carbon. And then on my 5th carbon, I have a T-butyl group. So that means I'm going to draw this going down and then like a T. Done. Okay? And then finally, the last one is 113355 hexamethyl cyclooctane. Hexamethyl means I have 6 methyls, and they're located on 1,1. They're located on carbon number 1 twice, carbon 1 twice. They're located on 3,3, which means carbon 3 twice, and then 5,5, which means carbon 5 twice. And a methyl group looks like this. It looks like a straight line or a CH3. And then cyclooctane, cyclo means ring, and then octane means 8 carbons that are all single bonds. So I need to have 8 carbons that are all singly bonded to each other that form a ring. That's basically a stop sign. One, 2, 3, 4, 5, 6, 7, 8. And then I get to number this however I'd like to. And now, on my 1st carbon, I have 2 methyl groups, 1, 1. 1, 1. On my 3rd carbon, I have 2 methyl groups, 1, 1. And then on my 5th carbon, I have 2 methyl groups. Done. Okay? So, if you had quiz B, you're going to go through and make sure you do these corrections. You put the correct answers and then tell me what you did wrong on the side, and you will get full credit back for doing this.